Welcome to the Math Critique and the TLDR on radians. If you want the full video, it'll be linked below. This is going to give you a quick view on what are radians and how to convert between radians and degrees. Okay, so it's actually going to be pretty easy to describe angle measures using radians. Okay, so to be able to do that, uh, you don't. You don't actually describe the angle measure. Okay, it sounds counterintuitive, but it actually works out pretty nice. Okay, so what I'm going to do is first off, uh, an angle is what you get when two lines intersect. So here's my first line, and here's my second line. Okay, so now I have two lines that are intersecting, and we're going to look at this region here to describe the size of the angle between them. Okay, so to do that, I'm going to put this on a coordinate plane. Okay, so that means this first line, the first line that was on the screen, this horizontal line here, that is going to be my x-axis, so I got to put in a y-axis, so I have a line going vertically. And what I'm going to do is I'm going to put a circle around that. Okay, now notice everything is focused here at the center of this circle. I have the angle, this is my original angle. I have the origin where the two axes meet is the center of the circle. Okay, now the nice thing about this is this going to be called a unit circle. Okay, so what that means is it's a circle that where the radius, the distance from the center to the side, is 1 unit. So that's why it's called a unit circle. It's 1 unit from the center to the side. Okay, and then what I can do is, instead of figuring out this space here in saying degrees, not really having a good definition of what degrees are, all I'm going to do is I'm going to find the arc length. I'm going to find this length around this outside of the circle. You might have heard of it described as if you were an ant walking around the outside of the circle, how far did you go? Okay, so that's what we're going to use to describe the size of the angle. So to do that, we got to start off by figuring out what is the circumference, the formula for the circumference of a circle. Well, the formula for the circumference of a circle is 2 pi r. Everyone always says pi r squared. That's area. Circumference is 2 pi r. 2 times pi times the radius. Okay, now we just said that because this is a unit circle, that means that the radius is 1. So if the radius is 1, I can just plug 1 in for r, and the circumference of the circle, if I walk all the way around the outside of the circle, all around, that ends up being 2 pi units. Well, if you think about what radians are, one full rotation around the outside of the circle is 2 pi radians. That's because that's one full circumference of the circle. So if you go all the way around the outside of the circle, that's the circumference. That's also the radians. Okay, so how does this help us to figure out how to find radians? That's an excellent question. So what we just determined is that all the way around the circle is 2 pi radians, because that's the circumference of the circle, 2 pi, circumference of a unit circle. Okay, so we know that the full circumference of the circle is 2 pi radians, which is the same as 360 degrees. Okay, so what I'm going to do, just to make this easier to see, is I'm going to get rid of these units. I'm going to get rid of where it says radians. I'm going to get rid of the degree symbol. I'm going to keep saying it so that it's easier to follow. Okay, so what this tells me is that 2 pi is the same as 360 degrees. So 2 pi radians is the same as 360 degrees. Which means if I divide both sides by 2, that means that pi radians is the same as 180 degrees. Okay, now I did that just because I wanted to get pi by itself. I wanted to get pi to be kind of the smallest unit. Okay, And the reason I did that is because that's going to help us out here when we do conversion. Okay. Now, before I move on, though, I do want to point this out. So 2 pi is the same as 360 degrees. That's all the way around the circle is 2 pi radians, and it's the same as 360 degrees. Halfway around the circle is 180 degrees. That's pi radians. So we just used math to show that this is true. Okay? You can keep going with this and you can say, oh, well, just half of that, that's a 90-degree angle. That's if I took that 180 and divided it by 2, I'd get 90. Pi divided by 2, we usually just leave it as pi over 2, and that's a 90-degree angle is pi over 2. So you can keep dividing this and you keep getting these angles, okay? But we don't always have nice angles that are easy to do this with. So it's really, we prefer having something we can just multiply by. So let's do that. Okay, so let's say I have 60 degrees. Okay, what I'm going to do to be able to change the 60 degrees to radians is I'm going to multiply by pi over 180. Now, big question always comes in here. Why do we multiply by pi over 180? Well, think of this like a fraction. If I have the same thing on top and the same thing on bottom, that means when I multiply, I'm multiplying by 1. If this was 4 over 4, that'd be 4 over 4 is 1, so you're multiplying by 1. This is how we convert fractions. We change to common denominator to get common denominators, and you multiply top and bottom by the same thing. It doesn't change the value. So here we're going to multiply by pi radians over 180 degrees because those are the same. And when I multiply that, I get 60 divided by 180 is 1 over 3. And then the pi stays right where it is. So this is pi over 3. And you can check the math on that if you need. So 60 divided by 180 is 60. You cancel everything out. You get 60 is 1. 60 cancels out and you get 1. 180 cancels out, you get 3. However you do that in your class. So you can go through and you can reduce the fractions just by multiplying them. So if you want to go from degrees to radians, multiply by pi over 180. Let's say I want to go the other direction. Okay, so now let's say I have 3 pi over 4. Well, if I want to change this to from radians to degrees, it's actually a lot simpler than it sounds because I just take that fraction, I flip it over. Okay, the 3 pi over 4 times 180, you can cancel these out however you want. Start off, look, there's a pi on top, pi on bottom, they're going to cancel. So you just have 3/4 times 180. Okay, so you can start off by doing that. Make the math easy on you. Once you go through and multiply that out, you find out that the degree is 135 degrees, the degree measure. So that angle is 135 degrees. 3 pi over 4 is the same as 135. The way, this may sound really too simplistic, but it's really the way I do it. The way I remember which value goes on top and which value goes on bottom is I remember all of my radians, I always have a pi in the top. So when I want to convert 2 radians, I need to multiply by the fraction with the pi on top. That's the only way I'm going to get my pi on top. So the 180 would have to be on bottom. And then you just flip that over to get go from radians to degrees.